Okay, so I just wanted to run through some of the exam questions that you had on chemical equilibrium. I posted these on the 7th of the 12th on Teams. So in the first question there, they gave you the manufacture of ammonia equation, which is the Haber process, and they asked you, according to Le Chatelier's principle, what effect would an increase in pressure have on yield of ammonia? So you need to be careful that you're answering the question. They're asking you the effect on the yield of ammonia, okay? Now, they're said that they increased the pressure. So remember, we would have said, what's the stress? Then what does the reaction want? Well, the reaction wants to decrease pressure. And then how is the reaction going to decrease pressure? By turning 4 molecules into 2, okay? Therefore, favouring the forward reaction. Or you could say that the equilibrium moves to the right. And what effect will that have on the yield of ammonia? Well, it will increase the yield of ammonia. Okay, so that's all you had to say there. And so you'll say you increase the yield of ammonia, and they ask you to explain why. Well, you're going to say that if the pressure is increased, according to Le Chatelier, the reaction will want to relieve that stress, or to decrease that pressure. And in order to decrease pressure, you need to turn 4 molecules into 2. Okay. Now, the next question then in the work that I posted talks about making hydrogen iodide. Okay. Now, they tell you there that the delta H is 51.8. Plus 51.8 means that the forward reaction is endothermic. So I'm say the backward reaction is exothermic. And you're thinking fire when you're thinking exothermic. Okay. Now, they're asking you the definition, that's fine, and the calculation, I'm assuming, is fine. Now, part C is what I want to do here. Stating Le Chatelier's principle, that's fine. Now, use Le Chatelier's principle to predict and explain the effect of a decrease in temperature. So use the prompts that we've been doing. So what's the stress? What does the reaction want? And how is the reaction going to achieve this? So the stress in the question is that you have decreased the temperature, okay? So you've decreased the temperature. So the reaction is going to want to increase the temperature, okay? And how will this particular reaction increase temperature? Favour the backward reaction, okay? Because that's the side that's exothermic. So this reaction will increase temperature by moving the equilibrium to the left, or by favouring the backward reaction. But you were specifically asked for the effect on the yield of hydrogen iodide. So you'd have to say if the backward reaction is being favoured, then the yield of hydrogen iodide is going to decrease. So you'd say decrease the hydrogen iodide concentration and the intensity of the colour. Now, they told you that hydrogen iodide was colourless, and iodine, they told you, was purple. So if you're going to move the equilibrium to the left, then you are going to see more purple, or the purple colour developing, or something like that, okay? The last part of that then said, what change, if any, will an increase in pressure have on the equilibrium mixture? Now, increasing the pressure there is going to have no effect on the position of equilibrium, because the number of moles is the same on both sides. You have 1 and 1, 2, and you have 2 on the other side. And if you have the same number of moles, then changing pressure isn't going to change the position of equilibrium. And then for question 3 then, it went back to the manufacture of ammonia. Okay, so the reaction was given to you there. And then they gave you data. Okay, so they told you that, so you have temperature here, right, 573, 673, 773, and going down, then the pressure is increasing, 200. Okay, and the first question that they are, and then in the middle, then they have the yield of ammonia. Okay, so 92 is down here, which is the biggest number. So the first question is, from the table, the conditions of temperature and pressure at which the highest yield of ammonia is obtained. Well, 92 is the highest yield. So it's 1,000 atmospheres and 573 Kelvin. Use your units now as well. Now, for part 2 of that then, okay, they ask you to deduce from the data whether this reaction is exothermic or endothermic, and to explain your reasoning. Now, lads, if you look at the temperature going up here, so 573, 673, 773, what is happening to the yield as the temperature increases? So decipher that. As the temperature increases, I can see that the yield is decreasing. Okay, so go through my prompts. So what's the stress? what would the reaction want to do in order to relieve the stress, and how would the reaction achieve this, okay? So the stress is I'm increasing the temperature, and what happens is that you get a decrease in the yield. So by increasing the temperature, the equilibrium must be moved to the left, or the backward reaction is favoured, because it tells me I'm decreasing the yield. So if I increase the temperature, according to Le Chatelier, the reaction will want to decrease the temperature, and the reaction is decreasing the temperature by moving the equilibrium to the left, okay? Therefore, the backward reaction must be endothermic, okay? The backward reaction must be endothermic because that's absorbing heat, or it's decreasing the temperature, okay? Which would lead me then to deduce that the forward reaction must in fact be exothermic, okay? So I'm just going to run through that now again for a second, okay? So what did they tell you in the question? They told you to use the data, all right? And they told you to deduce which reaction was exothermic, which reaction was endothermic. When you look here, as you increase temperature from 573 to 673 to 773, the yield of ammonia is decreasing. So increasing the temperature must cause the backward reaction to be favoured. Okay? That's the stress, increasing the temperature, and this is the effect. Backward reaction. Equilibrium moves to the left. And why is the equilibrium moving to the left? In order to decrease the temperature. So the backward reaction must be endothermic, must be absorbing heat. Okay? Identify problems associated with use of high pressures. They're potentially explosive and expensive to generate. Writing the constant, Kc constant should be fine. And then stating the effect on the value of Kc if using a catalyst. There is no change in the value of Kc if a catalyst is used, okay? A catalyst will speed up the rate of the forward and the backward reaction to the same extent. So you will reach the position of equilibrium quicker, but there'll be no change in the value of Kc. Remember to say the only thing that will change the value of Kc is the temperature and how the actual reaction is balanced. Okay, thank you.